143. Finite Mathematics. In the previous lecture, we introduced the basic language of probability. We learned about experiments, outcomes, sample spaces, events, unions, intersections, complements, and mutually exclusive events. Today, we are going to take the next step. We will begin assigning numerical values to events. In other words, we will learn how to calculate probability. By the end of today's lecture, you should be able to define probability, distinguish between theoretical and empirical probability, compute probabilities in uniform sample space, use the basic properties of probability, calculate event probabilities by adding simple event probabilities, and solve problems involving dice, cards, coins, and experimental data. Okay, then let's begin with the probability. What is probability? Okay, probability measures how likely an event is to occur. Probability measures how likely an event is to occur. We write probability of E to mean the probability of event E. So, let's say one more. Probability of A, the probability of event A. Probability of B, the probability of event B. Also, probability of heads means the probability of getting heads when tossing a coin. Okay, then let's say the probability scale. A probability can never be less than 0 or 0 and can never be greater than 1. So, a probability can never be less than 0 and can never be greater than 1. So let's say the probability of event E, probability of event E greater than or equals 0, less than or equals 1. The endpoints never less than 0 and never greater than 1. So probability of E, probability of event E equals 0 means event is impossible. Probability of event E equals 1 means event is certain, the certain event. The probability near 0 means the event is unlikely. A probability of a probability of event near 1 means the event is very likely. Okay, let's see the quick example. What is the probability of rolling a 7 on a 6-sided die? The answer should be 0. A probability equals 0 means event is impossible. And what is the probability of rolling number between 1 and 6? So the answer should be 1. That means event is certain event. Okay, then there are two main ways we can calculate the probabilities. There are two main ways. So, two types of probability. The first one is theoretical probability. Theoretical probability is based on the mathematical structure of the experiment. So, based on the mathematical structure of the experiment, if all outcomes are equally likely, if all outcomes are equally likely, then the probability of E could be the number of favorable outcomes over total number of possible outcomes. This is the probability we expect mathematically before carrying out the experiment. Example, for a fair coin, the sample space head, tail. There is one favorable outcome for heads and two possible outcomes. There is one favorable outcome for heads and two possible outcomes. Therefore, probability of getting head equals 1 over 2.5. Okay, what about the second type? The first type is the theoretical probability. The second type is the empirical probability. Empirical probability is based on actual observations or experiment. Based on actual observations or experiments. Okay, we calculate it using the relative frequencies. We calculate it using relative frequencies. The relative frequency equals the number of times the event occurs over total number of trials. So the theoretical probability tells us what we expect. The empirical probability tells us what actually happened. Theoretical tells us what we expect. Empirical probability tells us what actually happened. Okay, let's see the example. Suppose a coin is flipped 100 times and heads occurs 58 times. Then the empirical probability is probability of getting head. So the number of times that event occurs, 58 out of 100, the total number of trials, 0.58. The theoretical probability is still 0.5, but the empirical probability is 0.58. Does getting 58 heads means the theoretical probability was wrong? No. With a limited number of trials, empirical results will usually vary. As the number of trials increases, the empirical probability often moves closer to the theoretical probability. Important. No. With a limited number of trials, as the number of trials increases, empirical probability often moves closer to theoretical. Probability. So then let's see how to compute the probability of an event. Suppose the sample space is S contain S1, S2, S3 up to n observations and n outcomes. Each sample point has a probability. Right? If an event E contains several sample points, then its probability is found by adding the probabilities of those outcomes. If an event E contains several sample points, then its probability is found by adding the probabilities of those outcomes. So that means probability of event E equals the sum of probability of sample points. More explanation. Let's see. Suppose event E contains S1, S2, S3, three sample points. Then probability of event E equals probability of S1 plus probability of S2 plus probability of S3. Add in all probability. An event may contain more than one outcome, so we add the probabilities of all favorable outcomes. Okay, then we need to know the basic properties of probability. Let's see what are the basic rules. Basic properties of probability. There are three important rules. Rule 1, each simple event probability satisfied 0 between probability greater than 0 less than 1. Each simple event probability satisfied the rule between 0 and 1. Rule 2, all probabilities in the entire sample space add to 1. That is, the probability of sample space equals 1. Let's say probability of S1 plus probability of S2 plus up to probability of Sn equals 1. Rule number 3, every event has a probability between 0 and 1. That means the probability of event E between 0 and 1, if probability of E equals 0 means impossible event, again recall the impossible event. Probability of E equals 1 means the certain event. Okay, then let's see the uniform sample spaces. A uniform sample space is one in which all simple outcomes are equally likely. A uniform sample space is one in which all simple outcomes, all are equally likely. So that means every outcome has an equally likely chance to occur. If there are n equally likely outcomes, then each has probability 1 over n. Let's see. So, if there are n equally likely outcomes, then each has probability 1 over n. If event E contains m favorable outcomes, then probability of E equals m over n. This is the basic favorable over total formula. So let's see the example. A fair six-sided die is rolled. The sample space is S 1, 2, 3, 4, 5, 6. There are 6 equally likely outcomes because a fair six-sided die is rolled. Right? Then think about the event probability of rolling number 4. Only one favorable outcome number 4. Therefore, the probability of getting number 4 only 1 out of 6. The probability of getting number 4 1 over 6. So you can use the decimals 0.1667. Okay, next. What about the rolling and even number? Probability of rolling an even number. So, even outcomes are 2, 4, 6. There are 3 favorable outcomes. Right? So, therefore, probability of getting even number 3 out of 6, because out of 6 possible outcomes, 3 total favorable outcomes. 1 over 2.5. Okay, then next, let's move forward. 2 dice problem require a little more care. So when 2 fair dice are rolled, each die has 6 possible outcomes, right? Okay, let's go for the 2 dices. When 2 fair dice are rolled, each die has 6 possible outcomes, right? So using the multiplication principle, six times 6, 36 equally likely ordered outcomes. Right? If not, you can draw the outcomes. The first die with 1, first die with 2, first die with 3, first die with 4, first die with 5, first die with 6, then let's go for the second one. First die with 1, second die 1, 2, 3, 4, 5, 6. 6 possible outcomes. And also we can have 1, 2, 3, 4, 5, 6, 12, 6, 6, then 1, 2, 3, 4, 5, 6, again 6, then 6, 6, 6, 36 possible outcomes, right? So then think about example. Get in sum equals 7. Sum equals 7. So what are the outcomes? We can get the sum equals 7. Okay, 1 and 6, 7. Also 2 and 5. Also 3 and 4. And what are the others? So let's draw all here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, then the sum equals 7. 1, 6, 2, 5, 3, 4, and 4, 3, 5, 2, and 6, 1. There are 6 favorable outcomes. Therefore, the probability sum equals 7, getting sum equals 7 when 2 fair dice are rolled equals 6 out of 36, 1 over 6. In decimals. Okay, next let's see sum equals, getting sum equals 11. Sum equals 11. Okay, sum equals 11, only 2 favorable outcomes, 5, 6 and 6, 5. 5, 6 and 6, 5. Five, 6 and 6, 5. Therefore, probability of getting sum equals 11 when roll 2 dice, 2 fair dice, 2 over 36, 1 over 18. In decimals, 0.05556. Okay, then what about the doubles? Doubles are getting same number in both dices. So, example, doubles. So, the doubles are, what are the doubles? 1 1, 2 2, 3 3, 4 4, 5 5 and 6 6. Doubles are 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. There are 6 possible outcomes, equally likely outcomes. Therefore, probability of getting doubles when rolling two 6-sided dice, 6 over 36, again 1 over 6, 0.1667. Okay, let's see the next example. Example, sum equals 1. Can the sum of two standard dice equal 1? Can the sum of two standard dice equal 1s? No, the smallest possible sum is 1 plus 1, 2, right? Therefore, okay, so let's get, can the sum of two standard dice equal 1? The answer should be no. The smallest possible sum is 2, that means 1 and 1. Therefore, probability of getting sum equals 1 when rolling two standard dice equals 0. The event is impossible. The event is impossible. Let's see example, getting sum is 12 or less. 12 or less. Okay, what about the largest possible sum? The largest possible sum is 6 plus 6, 12. Therefore, every outcome satisfied the event. Therefore, every outcome satisfies the event probability sum less than or equal 12, so equals 1. This is a certain event. This is a certain event. Okay, let's move forward for the next example. So, a standard deck of cards a standard deck contains 52 cards, right? A standard deck contains 52 cards. There are 4 suites. There are 4 suites. Hearts. Hearts. Diamonds, clubs, and spades. Each suit contains 13 hearts, 13 diamonds, 13 clubs, and 13 spades. Then let's move forward. What about the probability? Drawing a heart. Drawing a heart. There are 13 hearts. Therefore, probability of drawing a heart 13 out of 52, 1/4. Then what about the probability drawing a face card? Drawing a face card. The face cards are Jack, Queen, and King. Jack, Queen, also King. There are 3 per suite and 4 suites, right? So there are 3 per suite and 4 suites. That means 3 times 4, 12 favorable outcomes. Therefore, probability of drawing face card could be 12 over 52, 3 over 13. Zero 0.23076. Right? Okay. Then let's move forward. Example. Consider 2 coin tosses. The sample space is head, 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 tail, tail, head, or tail, tail. Then each outcome has probability 1/4. Then now we are going to classify outcomes by the number of heads. The probability of 0 heads. Probability of 0 heads. Only one possible outcome TT. So the probability 1/4. Exactly 1 head. Probability of getting exactly 1 head. So there are only 2 possible outcomes with the exactly 1 heads, head, tail, tail, head. So 2/4, 1/2. Probability getting 2 heads. So 1/4, 0.25, 0.5, 0.25. Let's check the probability of sample space. That means probability of head, head, plus probability of head, tail, plus probability of tail head plus probability of tail tail. 1/2, 1/4, 1/4, 1/4 plus 1/4 equals 1. Also, sum of the all events could be equal 1. Therefore, getting 0.25 plus 0.5 plus 0.25 is also 1 because the entire sample space. Then, at least one head probability, at least one head. So, which outcomes contain at least one head? Head, 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 tail, and tail, head. Right? Therefore, the probability of at least one head equals 3/4.75. Okay, I hope everything clear so far. Then you can try the exercises in our materials by yourself. So, before we finish, let's review some common mistakes. Using favorable over total when outcomes are not equally likely. Forgetting to count the entire sample space correctly. Treating two dice are having only 12 outcomes instead of 36 outcomes. Confusing theoretical probability with empirical probability, giving an answer greater than 1 or less than 0, forgetting that all probabilities in a sample space must sum to 1, confusing at least 1 with exactly 1. So please keep these common mistakes. Please don't do that mistakes. Right? So let's summarize today's lecture. Probability measures the likelihood that an event will occur. We learned two types of probabilities, the theoretical probability based on mathematical structure and empirical probability based on observations. For equally likely outcomes, we calculate probability as favorable outcomes divided by the total outcomes. We also learned that every probability must lie between 0 and 1 and all simple event probabilities in a sample space must add to 1. Finally, we applied these ideas to dice, cards, coins, and experimental data. In the next section, in the next lesson, we will build on these ideas and study additional probability rules for unions, intersections, and complements. Thank you for watching, and I'll see you in the next lecture.